So the second part of 2.2 is talking about x and y intercepts and then linear equality. So not only graphing lines, but finding where they touch the x-axis. So the x-intercept is where it touches the x-axis. And y-intercept is where it touches the y-axis. In an x-intercept, the ordered pair is always going to be the number, comma, 0. And then in a y-intercept, it's going to be 0, comma, y. So the number will go first in an x-intercept, second in a y-intercept, which makes sense because if you're finding an ordered pair on the x-axis, you're going to go over to that number, and then your y value doesn't go up or down any, so that stays 0. To find these in an equation, you're going to let y equal 0 to find an x-intercept, and you're going to let x equal 0 to find a y-intercept. So it's the opposite. So for number 11, I want to find the x and the y-intercepts. To find the x-intercept, I'm going to set y equal to 0. So x minus 0 equals 4. So my x-intercept would be at 4, comma 0. And in fact, I'm going to encourage you to just do it all in your head instead of having to write out all the work. Just makes more sense. But if you want to write out all of the work, it's like saying x minus 2 times 0 equals 4. So then my y-intercept, if I'm setting x equal to 0, minus 2y equals 4. So y equals what? Negative 2. So my ordered pair is 0, negative 2. Another way to think about it is just covering up the x or covering up the y. So try number 12, x and y intercept. So like I said, you can just cover up the x, cover up the y. Then they'll get divided by negative 15. Good. The next thing is linear inequalities. So you're just graphing a line and then shading. The only difference is now whether it's a dashed line or a solid line. So the steps, you're going to graph the line. You're going to decide if it's solid or dashed. How do I know it's a solid? Greater than or equal to, or less than or equal to. How do I know it's dashed? Good. Then the last step is you're going to shade. Now, there's a couple things you can do when shading, but I don't like to make it too complicated. If it's a less than, then you're going to shade below. If it's a greater than, you're going to shade above. Another way to think about it is less than is to the left, greater than is to the right. If you're unsure completely, like you just don't know at all, a way that you can test it is by plugging in 0, 0. So if I plug in 0, 0 into the original equation, like even on number 3, before I even do anything, if I plug in 0, 0, I get 0 is less than negative 4. Is that a true or false statement? Yes, no, false. So that means I am not going to shade, so you don't shade at 0, 0. You shade away from it. So if I were to follow the steps on number 3, I'm going to plot my point at -4. Slope of 3, will I have a dashed line or a solid? Dash. So I'm going to plot my points up 3 over 1. I'm going to dash. And this is one where it gets a little tricky, like I don't exactly know where to shade, but I'm shading below. So this gets shaded, but another way to test it is by doing the 0, 0 test right here. So here's 0, 0. This statement is false, so I don't shade where 0, 0 is. And in fact, I'm going to go ahead and erase left and right because I think that can be confusing. I think let's just stick with below and above. I don't want to throw too many things out at you. So erase left and right. I want to take that away. Just keep above and below. And then if you're still unsure, do the 0, 0 test. But this shading right here is considered to be below because this value is less. So try number 4. Okay, looking at number 4, I'm going to plot my point. Y-intercept is at 5. Has a slope of -3, so I go down 3, right 1. I'm always going to go right. If it's a negative slope, that means I go down into the right. If it's a positive slope, I'm going to go up into the right. So down 3 over 1, it is a solid line. It is a greater than, so I'm going to shade above. Another way to test that, if you don't know which way is above, is to test out the point 0, 0. So I plug in 0 for x and y. I end up getting 0 is greater than or equal to 5. That's not a true statement, so I shade away from 0, 0. So you move the 2x over, divide by -6. That fraction reduces to 1 over 3. And it's positive 1 over 3 because you have a negative divided by a negative. And then 12 divided by -6 is -2. So I plot my y-intercept at -2. Up 1, right 3. It's a dashed line. Less than, so I shade below. If I tested 0, 0, you could test either here or here. Either one would work because they're the same equation. All I did was manipulate the second one, but they're the same thing. So if I want to test it in the original or in the slope-intercept form, does not matter. But if I test it in the original, I get 0 is greater than 12. That's not true. It's false. So no, so I shade away from 0, 0. But also shading below works. Number 5, y is less than or equal to 3. When it's a y equation, that means it's a what type of line? Horizontal. Hoi vux, remember. Shade below. Horizontal and vertical is really easy because shade above, shade below. You don't have any discretion there. It is literally, if it's a less than, you shade below, greater than, you shade above. Okay, number 6 and 7. Just deciding whether something is a solution is you're plugging it into the equation. So all you have to do is plug in the ordered pairs to the original equation. If you already have the graph drawn, which I erased mine, you just have to decide is it in the shaded area or not. So it helps when the graph is already drawn. So if I plot my point, I'm going to go back up a little bit and redraw it. There we go. Here's my shaded area. If I plot 0, -3, Is that a solution? Yes or no? Yes, because it's in the shaded area. 2, 2. Negative 3, 8. Negative 3, positive 8. It's going to be all the way up here. So no. Number 7. Here's another, it gives me now an equation, but I don't have the graph, so I can't just plot it on the graph. I'm going to plug in these values into the original equation. If it's a true statement, then yes, it's a solution. So true equals yes, false equals no. So 3 times 1 minus 4 times negative 1 is greater than or equal to 12. Yes or no? Okay, try B and C. Okay, here's what I got for A, B, and C. Questions about 2.2.